Hey there! Let's take a look at some of the properties of quadratic relations. So in standard form, it is expressed as y equals to ax squared plus bx plus c. Just like for linear relations, we had y equals mx plus b. For lines, we knew that b was our y-intercept and m was our slope. Likewise, for quadratic relations, a, b, and c tell us a lot about how the graph will look. For example, I can tell you that in order to see the y-intercept, you have to take a look at c. Just like in here, we took a look at b. Another thing is the importance of a. When a is greater than 0, the parabola is going to open up. And when a is less than 0, the parabola is going to open down. A cannot equal to 0 in quadratic relations because then this term will just cancel and we will be left with a line. See how bx plus c, if that were to be left over, looks like mx plus b. For the lines, we knew that when m was greater than 0, we had a positive slope. When m was less than 0, we had a negative slope. And when m was equal to 0, we just had a horizontal line, and that was equal to y equals to b. The other thing we did a lot is we tried to find the x-intercepts of the line. For a line, it's quite easy because all you had to do was set y equal to 0, and then from there solve x. So you could have just isolated for x and solved it. Now for quadratic relations, it's not as easy because if I were to just plug in y in here, I'd have two values for x I'm trying to find, and we will actually take a look at a bunch of ways on how to find the x-intercepts, also known as the zeros or the roots of quadratic relations. Another important point on the graph of a parabola is the vertex. When a is greater than 0, the vertex is the lowest point. And when a is less than 0, the vertex is the highest point. In order to find the vertex, it'd be useful to find the axis of symmetry, which is, just as you thought, a line that would separate the parabola into two, in which case this point and this point, if they are of the same y, would be the same distance from the axis of symmetry.